All right, so let's now that we've kind of introduced average cost and linear approximation, let's talk about minimizing average cost. So we kind of have these two graphs, and um, essentially average cost will start off higher because you have some fixed costs, and so you have you know substantial startup costs for whatever it is, and then the more you produce, the more it goes down. And then at a certain point, the more you produce, then market saturates and then average cost goes up. Um, and then you have marginal cost follows typically this route. Now, where does the marginal cost or where is average cost minimized? Um, so if the marginal cost is lower than the average cost, so the cost to produce one more item is lower than what it's cost to produce the item so far. Producing one more item will lower the average cost. On the other hand, if marginal cost is higher than average cost, then producing one more item will raise the average cost. So it's kind of like with your grades. If you get if your average is an 80 and you get a 70 on an assignment, that's going to lower your average. Or if you have an 80 and you get a 90 on an assignment, that's going to raise your average. So same idea here. So the minimum average cost per item occurs when marginal cost is the same as the average cost. So in this example, next example that we're going to look at, we have manufacturer, furniture manufacturer. We have the cost function. How many chairs should be produced to minimize the average cost of each chair? And so basically, and what this is saying, so marginal cost needs to equal average cost. So essentially, C prime of Q needs to equal C of Q divided by Q. And so that would tell us when the minimum average is. So we can set that formula up, and fairly easy to set it up, and usually pretty easy to solve. So take the derivative of C. So we have 5 plus 0.02 times Q, and then now C of Q divided by Q. So we have 10,000 divided by Q plus 5 plus 0.01 Q. So now we just need to solve for Q. So 5 will cancel, and we can bring this one over. So 0.02Q minus 0.01Q, that gives us 0.01Q equals 10,000 over Q, and then 0.01Q squared equals 10,000 divided by the 0.01, and we get Q squared equals 1 million. And then take square root, and we get Q equals 1,000. So producing 1,000 of these pieces of furniture, whatever they are, or chairs, I guess it says, producing 1,000 will minimize the average cost per chair. So simple as that. So this is just easy formula to remember, and then the problem's not too bad. All right, so next page, now revenue and profits. I'm sure you're familiar somewhat with revenue and profit. Total R of Q is the total revenue after producing Q units. Then average revenue, not surprising, would be R of Q over Q. And then marginal revenue, like I said, marginal always means derivative. So R prime is the marginal revenue. And then we get profit. So the profit function is found by subtracting cost from revenue. And then to maximize production, or to maximize profit, production should be increased as long as marginal revenue is greater than marginal cost. So R prime of Q greater than C prime. So suppose, so from the previous example, estimates that revenue realized by producing Q units is given by this function here. So what is the marginal revenue? So when 1,500 is produced, so we need to find R prime, so that'd be 48 minus 0.024 Q, and then we're going to find R prime of 1,500, and just plug in 1,500 to the Q and solve, and we get 12. So the revenue from producing an extra chair is 12. Determine the number of shares that the company should produce in order to maximize profits. So let's find where R prime is equal to C prime. And from the last example, C prime of Q was 5 plus 0.02 Q. So from what was that page? Page 3. And so we have R prime of Q. Let's set that equal to C prime of Q. And solve for Q. And so we'll bring the 0.02 Q over. We get negative 0.044 Q. And then bring the 48 over. So 5 minus 48 gives us negative 43. And divide both sides by the negative 0.044. And then Q is 977.27. Obviously, we can't produce, we're producing shares here. So let's round that to 977. All right. So basically, essentially, anytime in this section where we're maximizing or minimizing, we have the revenue and the cost, or the cost and the average cost, marginal cost and average cost, and we're going to set those things equal to each other. Then the last thing, we have cost and demand functions. So if the price of each unit is $1.20, how many units will be sold? So let's set the demand function equal to $1.20 and then solve for Q. So negative 0.01 Q, subtract 3.5, and we get negative 2.3. And then divide by negative 0.01, and we get 230. And then determine the production level that will maximize profit. So we need to find our revenue function, and revenue is just going to be Q times the demand function. So Q times 3.5 minus 0.01 Q. So 3.5 Q minus 0.01 Q squared. So then we can find our R prime. So we'll do this over here because we got to find, actually what we'll do, because we're going to set the R prime equal to C prime. So R prime of Q equals C prime of Q. So R prime would be 3.5 minus 0.02 Q. And then we can take the derivative of this cost function here. So that would be 1.26 minus 0.02 Q. And then plus 1, 2, 3, 4, 1, 2, 3, 4, actually be 0.00021 Q squared. So now let's solve this for Q. The Q terms cancel out, subtract the 1.26 from 3.5, we get 2.24 equals 0.00021 Q squared. And then we'll divide, we'll do this all at once so we don't clutter up things too much. And we should get Q equals 103.28. And again, we'll round to 103. All right, so a couple of formulas to remember here. Nothing too complex. This is more of a situation where you just need to practice this enough times where you get used to these terms and what these terms mean in terms of the formula. The formulas themselves are not too complex, but I would suggest practice this enough that when you see determine the production level that will maximize profit, it doesn't throw you and kind of get a blank stare and don't know what to do. So the more you practice this, the easier that will get, the more reflexive it will get. But if you have any questions, feel free to email me.